Okay, I suggest that we, in the order of the presenters, just to remember what was said, if you very briefly, using your statement, can summarize what your paper is about so that we also remember the first papers and not just the last paper presented.
So start things off. So low adhesion can be produced due to iron oxides and water alone. This can be used as an input value to a model, but it's not just iron oxides. It seems like many different pastes also cause this low adhesion. So we should look at more rheometry.
Thank you. And Bing Lu?
Okay. Water is as common contaminations between well and real. It can be sourced from heavy rain or light rain or moisture. So light rain or moisture may cause starvation condition. So we established the numerical model to investigate the effects of starvation. Okay.
Thank you. And Casey?
My statement is crack morphology is strongly influenced by the crack face friction. So basically, yeah, that's gonna, well, I don't know what more to say about this.
Okay. We can have questions later. And Matthew, finally, we have heard you.
So tagging this is linked to pickup, and this method would enable you to do loads of tests really quickly to help optimize that fact.
Okay, so all papers are open for discussion. So please, here in the front.
So the grease test is more of a cohesive measurement of the grease, but what about the differences in the greases and how they adhere to either end of your test apparatus? And that will also be considered with how they adhere to the wheel as it passes over the grease.
Yeah, so I guess you could make instead of having the two stainless steel plates, you can make those out of wheel and rail material and make them sort of roughness, which is more representative.
Right, but your test really measures the cohesiveness of the grease and how it's going to split. Yeah. But it's not the measurement of how the grease is going to stick to the wheel.
Yeah, that's true. Is that, sorry, I don't think I'm getting what your question is.
Because that will be a difference in the greases as well, that adhesion to the wheel or to the rail.
Yeah, that would affect, but I think because I've also done those pickup tests as well, it kind of has shown that this test, even if it is just measuring the cohesiveness within the grease, it still shows there is a link between that test and the sort of the pickup, and therefore the carry down on how much product gets where you want it to go.
I also have another question for Ben, if that's okay. And so during your, I think it was HPT you did on the iron oxide?
I did Suros twin disc test.
Suros, okay, so you only showed about 200 cycles. Is that because after that fact the water started drying and you started to see the rise, I guess, in the friction?
If you continuously added it, I only showed 400 cycles just to make it simple on here. If you continuously added it, you would get low adhesion for as long as you add the paste for. But if it did dry, I found that there was usually an adhesion minimum, and then it would rise back up again.
Okay, so it stayed a bit low adhesion for a little while.
For a while, yeah.
Okay.
I did some other tests where I actually coated the discs beforehand with paste and just checked how long it would produce low adhesion for.
Okay,
and that would vary.
All right, thank you.
Okay, thanks. I have one question about, because I'm quite interested in the details of your methodology. You told us that the creepage you selected is 2%.
Yes.
Yeah. So one question is about why you select such a parameter. Another two parameter is about normal loading and rolling speed. So it looks like there is no detailed introduction about these two parameters. So if possible, I hope you can let us know why you select that normal loading and that rolling speed. Okay.
So I used 2% slip because that was the minimum we could produce while using water anyway that would produce a saturated slip value, so saturated traction coefficient. So that was the minimum I could use. Any more than that, I actually found that I had to add far more iron oxide. I could produce the low traction, but I think due to the increased slip and much harder contact conditions, a lot more was flung out of the contact. So we used the minimum possible value that would produce the saturated slip. And we couldn't vary the speed of the rig, so I had to leave that consistent.
Okay, I mean, for your test, what kind of rolling speed and normal loading did you select for your test?
So it used 1,500 megapascals, and speed was 400 RPM, which equates to 0.1 meters per second with the small disks. It would be nice to be able to scale that up and do a lot faster tests.
Okay, thanks.
Okay.
First question's for Ben. Under high conditions of temperature and creep, magnetite or Fe3O4 is also present in the wheel-air interface. Did you consider doing similar tests on Fe3O4 as opposed to hematite, Fe2O3?
Yes, I did, and surprisingly low adhesion couldn't be produced with magnetite. It was just hematite. Hematite actually produced a stable suspension when it was mixed with water, whilst at least the magnetite powder that I used separated very quickly, so sank to the bottom. And this meant that before it had entered the contact, I think anyway, it had actually separated rather than producing this stable paste. But I did some work looking at the iron oxides that were found on the railhead, and hematite was found there. Interestingly, throughout these tests, some of the oxide actually changed composition during the test.
That's because you're looking in Britain. If you look in desert conditions, very hot, there's magnetite. Question for Casey. Your results are dependent on rotational direction. Why is that?
I think that it's because the machine surface that we use, the test bars were prepared in a turning machine. So I think probably just the initial, the kind of spiral that they have, I think there's one direction which might be more preferential because of I think it's the initial machining conditions. So we're planning on grinding, polishing the surfaces and to a certain roughness and seeing if the dependence is still there.
I have a question for the first presenter, too. Can you elaborate the difference of the contact in your test and the contact in the real world, view the real contact, and how for you, yeah,
For me.
and how this difference will influence your extended for the friction modifier?
Well, the test isn't meant to be representative of the real world contact. The idea is that it's much easier to do and much simpler, but the idea of it is it gives you comparison between products, and that comparison has been shown to be the same when you do like a similar pickup test on the full-scale rig as well. Yeah.
Thanks.
I have a question to you, Bing. You showed us very nicely how the thickness of the oil film influences the phenomena, influences the results. In reality, would it be possible to control the thickness in such a detailed way? You showed results up to 4 millimeter. This happens, and if it's thicker, then you get other effects and so on. What does it mean then for reality out in the field?
Film thickness in reality, you mean?
Yeah, if you are out in the real system, can you control this
Control the film
thickness?
thickness?
Because your results say you should have this or that
No.
thickness, or
No. And in reality, the film thickness is affected by various factors, such as train speed and the surface harassment. So, in my opinion, it's hard to control the film thickness. In the simulation, we can make some assumptions, so we can calculate or simulate the film thickness. In fact, we can't control it in the running condition, I think.
Yeah, that was my feeling also. You had a question here in the back.
And I have a question for Matt. And you said the environmental chamber can be added in the future to control the humidity or temperature. And I'm not quite sure how the humidity influence your result or your test. So could you please tell me your expectation or opinion how the humidity influence your work or your test?
Well, I guess the point is that I don't know either, but with the humidity chamber, you'll be able to figure that out because the chamber just basically wraps around the module there, and so the specimens are inside there, so you can control the conditions better, and yeah, you'll be able to see how that changes. Because obviously, if you even in the UK, the difference between summer and winters can be quite large, so you'd want to make sure that whatever product you've got is working the same in the different conditions that you have.
Okay, thank you.
I have one more question for you. Casey, I have seen in the dry cases you have very high friction coefficients. I think up to 0.9 was the highest friction. Yesterday we talked so much about Kalker, and in Kalker's theories the highest friction coefficient for dry friction is always 0.6. So why do you get so high friction coefficients?
I think because the way that I measured the coefficient of friction was just the normal force and then the average radius and then the torque, which was measured from the machine. So I think there's maybe some other aspects which are coming into it that I haven't processed the information more than that, just taken out the value. I think maybe the actual values themselves are not necessarily perfect, and there's a lot of variation within a single rotation. So I think maybe an average inside that would be more representative. But for the moment, this is the values as I got them just there. But there could be something more within the machine, or the measurement also of the torque is based on this extensometer. So there can be everywhere a little bit something that adds to some more, more friction happening.
Yeah, but I can say I have seen other papers where people come up with higher friction coefficients than 0.6. So probably there's not a real upper limit there. Okay, thank you. Yeah? Here's one more question.
So, Casey, I'm just looking at your discs, your samples. I'm just wondering, I'm not, I don't know too much about materials, but my question is it realistic in terms of railway to kind of rub two materials and have such a large surface area? Is that realistic of a real wheel-rail contact? And do you have different, morphologies?
I was mostly interested in the crack face friction. So if you would have a crack, and then inside with the motion, then the loading that you have, this kind of sliding, I think that the rotation in these contacts is quite representative of what you would have in a crack.
But in terms of, because it's a point load and it's sliding, rolling contact, is that representative?
I don't think so in that case, no.
Okay, I just wanted to understand. Thank you.
So, anything else? Okay. Oh, everyone is satisfied? Okay, then we are also almost finished. So I would like to end the session with thanking mainly you for your very, very nice presentations. Excellent timekeeping also from all of you, I can say. Makes life very easy for the chairman. Thank you all for listening and for the lively discussion we had. So, okay, let's give them another hand, all the presenters.